Hello everyone, how are you? I'm ASM Dilzer before you, and today's class is all about English version. So you're the students who are reading in English version. So this class is only for you. Welcome to our GSC online school. So today's topic is about Theorem 1 from your textbook. Okay, you know there are two theorems in your book. So today our first theorem we'll discuss about. So before starting Theorem 1, we should know something what really Theorem 1 mean. Okay, so what is Theorem 1? It's so simple things. Just take a look here. It's all about a line and array. Theorem 1 tells us that if array, so what is this? This is array, this is a ray, and this is a line. If array meets a line, if array meets a line on a point, so how many angles you can see here? So there are two angles are formed. Here two angles are formed. You can see these two angles are called adjacent angles. These two angles are called adjacent angles. So one thing, do you know what is adjacent angles? At first you should know what is adjacent angles before proving Theorem 1. Okay, let's back to adjacent angles first. So for having adjacent angles, of course there should have two angles. Okay, having a common vertex and a common side, and the angles should lie next to each other so that the two angles will be called adjacent to each other. Take a look here first. Okay, we'll draw two angles first. After having one angle, we'll draw another ray so that the angle divide into two angles. Okay, clear? Now you can see here, you can see two angles. If we name these points A, O, B, C, okay? Now if I write AOC here, what is the name of this angle? AOC. What is the name of this angle? BOC. If I write AOC, if I write BOC, so what is the common things between the two angles? Here you can see O is common, right? If we call AOC, O is common. If we call BOC, so O is, for both the angles, O is the common vertex. So being adjacent angles, of course there should have a common vertex. So O is here common vertex. And another thing is there should have a common side. You can see if we write AOC, there is OC. If we write BOC, there is also OC. So OC is a common side. For having the vertex, common vertex and common side, AOC and BOC, these two angles are called adjacent to each other. Always remember, for having called the name of adjacent angles, of course there have two angles minimum, like corresponding angles, alternative angles, vertically opposite angles, then supplementary angles, complementary angles. So all these angles have two angles, right? So without one can't express as adjacent. If we only talk about AOC can't be adjacent. Okay, so for having adjacent to call, of course there should have two minimum angles. Now have you clear about adjacent angles? So having adjacent angles, the two angles should have a common vertex and a common side. So what is the definition of adjacent angles? Okay, so you should write as the definition of adjacent angles, the angles having a common vertex and a common sides and lying next to each other, is called alternative angles, alternative angles to each other. Clear? Now what is all about the Theorem 1? So here is a line. Suppose the line name is AB. We name the line AB and there should have a ray. So name this ray OC, okay, and the meeting place where the ray OC meets AB, so the meeting place name is O. Now you can see these two angles, so you can name them now, right? So you know, if two angles having a common vertex and a common side and lying next to each other are called adjacent angles to each other. So these two angles are adjacent. So this is what theorem 1 tells us to prove. So what we need to prove in theorem 1? We need to prove that sum of these two angles, which two angles? Produce two adjacent angles. Sum of these two angles is equal 180 degree or 2 right angle. So this is all we need to prove. So now at first we will write what? We'll write the question first. What is the question? So in your question, the question will ask for to prove that if a ray meets a line on a point, prove that. In the question it will be asked to prove that, but in our answer sheet we will write what? It is required to prove. We will not write prove that. Okay, so for instead of prove that, we will write what? It is required to prove that. Okay, clear? Now right, so I am just solutioning this. Okay, I am just giving the solution, I am not writing the question. So what we will write? If a ray meets a line, two adjacent angles are formed. It is required to prove that. It is required to prove that sum of the two angles is equal to 180 degree or 2 right angles. Okay, so at first we'll write this one. Clear? After that we'll draw the figure. So we'll draw the figure. Here is the line, so name the line as you want. So I am naming this line AB. Clear? So AB is a line, so O is a point on it and a ray OC which meets AB at O. Here two adjacent angles are already produced, so it is required to prove that sum of these two angles will be equal to 180 degree. Okay, tell me one thing, that a straight line is equal to how much degree? So it's a silly question, right? We all know that a straight angle is equal to 180 degree. Okay, so just think about it. If the ray is not remaining here, okay, so AOB like this one will remain. So if this one is equal to 180 degree, so these two sum of these two, why not it will be 180 degree? So simple, right? But we are going to have the proof. We need to prove it. How? Why it is 180 degree? Okay, so this is the question. For proving purpose, we'll draw one thing. Its additional drawing is required. So what will be the additional drawing? Here, from O, Okay, from O we'll draw a perpendicular. We'll draw a perpendicular. So name this perpendicular OD. OD is a perpendicular. So do you know what is perpendicular? We know that the sides of a right angle, are called perpendicular to each other. So if two sides are perpendicular to each other, of course the angle between the two sides will be 90 degree. So tell me one thing, if OD is perpendicular to OB, here OA is perpendicular to OD, right? So this angle will be equal to 90 degree, clear? And again, just think for a while, OC is not remaining here. OC, just vanish OC. Okay, think that OC is not here. Now OB and OD also perpendicular to each other, right? So this angle will also be 90 degree. So 90 degree plus 90 degree is equal to 180 degree. It's so simple, right? But we need to prove. Okay, here OC is getting back its own place. Now write it fast. Let AB is a line and OC ray meets AB at O. As a result, AOC and BOC, AOC and BOC, how many adjacent angles? Two adjacent angles. Two adjacent angles are formed. Okay, it is required to prove that AOC plus BOC is equal to 180 degree or two right angles. So what have I told you? So for proving purpose, we'll draw a perpendicular on AB at O. Okay, we draw. We draw a perpendicular OD at O. Okay, now proof. How to? Suppose OD is not here. OD is not here. So what will be? It's equal to prove that AOC plus BOC. Clear? Now just think AOC. Just only think there is only AOC and here is OD. So after breaking at OD, AOC is divided into two angles, right? So what are the two angles? AOD and DOC. So if we divide AOC, we get two angles. So write, in case of AOC, we'll write AOD plus DOC. Okay, and BOC, keep that same. there is no work of it. Okay, now one thing, what is the measurement of this angle as OD is perpendicular to OB? You know, of course you're thinking that this one should be 90 degree. Why? As OD is perpendicular to OA, so AOD is 90 degree. So keep that remain. AOD, we won't touch AOD, as we can write instead of AOD we can write one right angle or 90 degree, right? So keep that remain. Okay, so write AOD. Now just think about it. DOC plus BOC, if we add these two, DOC, if we add these two, this one and this one, DOC plus BOC, if this one is 5 taka and this one is 5 taka, so what is the sum? 5 taka plus 10 taka, right? 1 not 10 taka. So this and this, if we add these two here, DOC plus BOC, DOC plus BOC, so what will be the name of the angle if we add these two angles? So this angle will be BOD, like DOB, here is C. See, if we want to combine these two angles, and we are going to have the name of these two angles if meets, then what will be the total? Just remove this OC, then what is the name? BOD. So so what is the sum? If we add these two angles, this will be called BOD. So keep these two in the same angle. So what is the name of the angle after having these two angles sum? BOD. Now tell me, AB was a line and OD is the perpendicular. If OD is the perpendicular, this one is 90 degree. If this one is 90 degree, this one must be 90 degree, right? So this one 90 degree, this one is also 90 degree. So what can we write? We can write here one right angle plus one right angle equals equal to what? Sorry, what is the sum? Two right angles or 180 degree. So it is proved, right? Proved. And you need to give a side note. So what will be side note? As here you can take a look here, we divide AOC, we have divided AOC for AOD and DOC. So what have you done? You just write the same. AOC is equal to AOC, after dividing AOC we got two angles, so AOD plus DOC. So this one is a side note, and another side note is here. So after getting the sum of these two angles, write as DOC plus BOC is equal to BOD. And here these two angles are right angles. You should write this also as your side note. We know that OD is perpendicular to OB, so that both side of OD will be right angle produce. So AOD and BOD, both angles will be what? Right angle. So this is all about our theorem 1. Is it so hard, so tough? I think no. It's so easy. So keep practicing. So all these are for understanding purpose. We'll just draw this figure only. Okay, so this is all about theorem 1. So in our next class we will discuss about theorem 2. Till then, Allah Hafiz.